we have done amplitude and vertical shift, and those are the two that affect the y coordinate of our graph. Today we're going to look at one of the attributes that affects the x coordinate, and that is the period of a function. So first of all, understanding what the period of a periodic function is would be helpful. It's the distance along the x-axis that the function has to travel before it repeats itself. So get that written down. Okay, so the sine and cosine function are both periodic functions. That means they repeat. So to define or find the period, we're trying to see along the x-axis how long it takes before it starts to repeat. Repeating means you could trace it and then slide it and it'll fit exactly on. So how far along on the x-axis before we repeat? So I'm going here. Does it start over now? So here we go, up, down, back to the axis, and then I would go up, then I would go up, down, back to the x-axis. So this is the distance it takes to repeat. What is that distance on the x-axis? 2 pi. So the period of the sine function is 2 pi. We'll write that down in just a second. And then the same thing on the cosine. It's periodic. So how long before on the x-axis, what's the distance on the x-axis before it starts to repeat? So if we started at 0, our graph starts at 1, goes down below to 1, back up to 1, and then it starts to repeat again, right? So the same distance from here to here is how long it takes before our function repeats. And that again is 2 pi. So in your notes, let's go ahead and identify that the sine function, the base function, y equals sine of x, the period of it is 2 pi. And then for the cosine function, the same thing, the period is 2 pi. So we can look at equations and determine the period of a function. And here are the two adjustments, or what we're looking for in our equation. So we are looking for y equals sine of something times x, in parentheses, or y equals cosine of the quantity bx. And so from what's in parentheses with the x, what's being multiplied, or the coefficient of x, that's how we derive the period. So we take the b value, and we're going to take 2 pi divided by that b value, and that will be the period of the function. So notice in our y equals sine of x, what's the coefficient of x? How many x is that? 1x, right? If it's just written as x, we have 1x. So the coefficient, or b, is 1. 2 pi over 1 is 2 pi. So that's why the period of the base function y equals sine x is 2 pi, because b is 1. Same thing for cosine. This is 1x, 1 times x. So b is 1. Plugging that into this formula, 2 pi divided by 1 is 2 pi. That's why the base function of cosine has a period of 2 pi. So again, we said that the period affects the x coordinate. So when we do our t-chart, we'll be working with the x coordinate. Okay, bless you. So we're going to, for each of the problems, that first problems we're going to state the period and then adjust the t-chart for that change in the period of our function. So much like we did with amplitude and vertical shift, we worked with the t-chart and adjusted the y values and then graphed the final. That's what we're going to do with the period and then eventually the phase shift. Much easier to do it this way than it would be to graph each change like we did initially for our phase shift, no, for our amplitude and vertical shift. Okay, so our first equation is y equals the sine of 4x. So we are going to first determine what b is, and then identify the period, and then we're going to adjust our t-chart. So remember, b is what is the coefficient of x, and what is the coefficient of x in this? So b is 4. And then to find the period, we take 2 pi over b, and in this case, b is 4. So the period of our function is pi over 2, or a half pi, as some people say. Okay. So now we're going to look at our t-chart for the sine of x. And I don't know if you remember what those values are, but when x is 0, the sine of x is 0 as well. When x is a half pi, the sine of a half pi is 1. Then we have 0, -1, and 0 again, I believe. Do you remember that? Recall that? Okay. All right, so how we're adjusting our t-chart is that now this needs to be, instead of 2 pi, it needs to be a half pi. So we're going to multiply. So we have to take 2 pi times some number that will give us a half pi. So what is that going to be? If you don't know, then I'm going to say let's put W in there, and we want to solve for W. Yeah. So we would have to divide both sides by 2 pi, right? Dividing by 2 pi is the same as multiplying by its reciprocal. And you'll see pi's cancel, and we would get 1 over 4. So that's the factor we're going to multiply all of our x's by in order to get our new t-chart. So I'm going to take my x's times 1/4, however you want to write that, but neater than what's happening up here because it doesn't look very good. So each of my x values are going to be multiplied by 1/4. Y stays the same. Y is not changing. So 0, 1, 0, -1, and 0. Y is not changing. We don't have an amplitude change. We do not have a vertical shift. We just have a change in the period. So 0 times 1/4 is still 0. 1/2 times 1/4, 1/2 pi times 1/4. 1/2 pi times 1/4 is pi over 8, or an 1/8 pi. We can say it that way. Pi times 1/4 is a 1/4 pi, or pi over 4. 3/2 pi times a 1/4, so 3/2 times a 1/4 would be 3/8. 3 pi over 8. And then 2 pi times a 1/4 would be half pi. So my lines aren't really lining up there. Sorry about that. Okay, so we have to figure out what we have to take 2 pi times to get a half pi, or whatever the period is in the problem. And there we've adjusted it. We'll talk about graphing tomorrow. Or maybe today, we'll see. For this equation, it is y equals cosine of x over 2. What's another way we could write this, bless you? X divided by 2 is what? 1/2 x. So we could write that as 1/2 x. So b in this case is 1/2. And then to find the period, we always take 2 pi and divide it by whatever b is. So 2 pi divided by 1/2 is going to give us 4 pi. So I think you're going to like it when it's an x over a number, because the multiplying is going to be kind of simpler, I think, than if it was a whole number. You're going to end up with a fraction. Here we get 4 pi as the period. So this is my chart for the cosine. I could fill these in. I think it's going to be 1, 0, -1, 0, 1, correct? And we're going to do a new t-chart, but remember our y doesn't change. So we have 1, 0, -1, 0, and 1. X changes. So the original function or base function y equals cosine x, the period is 2 pi. We want it to be 4 pi. So what do I have to take 2 pi times to get 4 pi? So I'm going to take all of my x's times 2. And then that's going to give me the following. 0 times 2 is 0. 1/2 pi times 2 is just pi. 2 times pi is 2 pi. 2 times 3/2 pi is 3 pi. And then 2 times 2 pi is 4 pi. And I don't have those lined up right. So we have pi here, 2 pi, and 3 pi. All right, there we go with that one. Let's see. Okay, so we have two things happening to our t-chart, and we can probably do them on in the same step. One of these affects the y, so that's the amplitude. So what does the amplitude? What do we do with the y value? So we're going to multiply the y value by 4. And then the period is 6 pi. Originally it's 2 pi. What do I have to multiply 2 pi by to get 6 pi? 3. So I'm going to take my x coordinate times 3. And I feel very confident that you will be able to do that in one step. So each of the x coordinates you're going to multiply by 3. Each of the y coordinates you're going to multiply by 4. On our graph paper, we need to decide what each of those marks is. And I would go with what we have on our table. So 0, our new table, 3/2 pi. So this would be 3/2 pi. Then this is going to be 3 pi. This is going to be 9/2 pi. And then 6 pi. And then we want to extend that out. So we're graphing 2 periods. So that means I'm going to go out to 12 pi. So this is going to be 9 pi. This will be 15 pi over 2. And this will be 21 pi over 2. And then I think it's sufficient to let each mark on the y-axis just equal 1. So now we're ready to graph our function. The sine of 4 sine of x over 3. So we have the point 0, 0. That is there. At 3/2 pi, we're going up to 4. At 3 pi, we're at 0 again. 9/2 pi down 4. 1, 2, 3, 4. 6 pi at 0. And then the pattern repeats because it's periodic. So we're up to 4, 0, -4, 0, and we can graph the sine curve. And that is 2 periods of that function.